Thank you all for coming on this session about Cilium Service Mesh without the mesh, without sidecars. Today I'm going to explain why this is different and what we think you could benefit from it. My name is Raymond Jong. I'm Field CTO at Isovalent. Isovalent is the company behind Cilium. We created Cilium, originated Cilium, donated it to the community, and together with the community and a lot of other companies, we're maintaining Cilium as an open source project. And we're also maintaining eBPF, which is the underlying technology we use throughout Cilium, and we also use for a big part in Service Mesh. So I briefly want to see hands who has knowledge or experience with Cilium. Few hands, good. So I suppose not a lot of you know what eBPF is? No? Okay, good. So for that reason, I'll start with a brief introduction of eBPF and introducing Cilium and how we were using it in Cilium for different solutions. And after that, I'll dive into some of specific Service Mesh features and how are we using eBPF there to enhance and lower latency and so forth. I also prepared a demo, so fingers crossed the demo works. It's about Service Mesh, it's with Cilium, but also a bit of a Gateway API demo. And I'll show how it integrates, or how Cilium as a Gateway API controller enables you to do layer 7 routing and as such. So first introduction, eBPF. eBPF stands for Extended Berkeley Packet Filter. Doesn't mean a lot, but what it means for us, it makes the kernel programmable in a dynamic and secure way. It allows us to, since everything goes to a kernel, we can attach dynamically eBPF code to such events. So in the context of today, we run eBPF on networking-related events. So we use this to, for example, get effectively metrics once, let's say, a network interface sends packets on the wire, or when a process opens a socket, we can see that as well, and we can use that information in Cilium as well. We use it to enforce, for example, network policies or to attach an identity to the data plane, and we can observe that traffic, for example, using Grafana. Cilium is built on eBPF. You don't have to know everything about eBPF to run Cilium. Cilium abstracts this technology for you based on the configuration you set. And it basically provides all the networking load balancing capabilities in your Kubernetes clusters, also across clusters. All the observability tools you need to observe traffic. We also have a Hubble component, which is a UI to show service-to-service communication, ingress, egress connections going in and out your namespaces. And obviously security. We can use network policies, encryption features to secure your workloads. So this is the 30,000 feet view. For Cilium, it doesn't matter where you run your clusters. It can be on-prem, it can be on OpenShift, on VMware-based clusters, bare metals as well. As long as the kernel is of a decent version 4.9 or later, then you are able to use Cilium. Obviously, all the network features are there for you to use. Also, encryption, IPv4, IPv6, network policy support. On-prem, we can enable BGP, so we can speak BGP to the physical network to, for example, advertise load balancing IP addresses. On top of that, we've built Hubble. That's our observability layer, provides a UI, a CLI, exporting metrics to Grafana as well. And today we're focusing on the Service Mesh layer we introduced a year ago with ingress, authentication, traffic management support. We also have a runtime security component, which is able to attach eBPF programs on runtime events. We're not going to talk about that today, but there's some interesting content out there to learn more about that. So let's talk about Cilium Service Mesh. What is different with Cilium Service Mesh compared to other service meshes? I sometimes have the analogy, imagine you need to cut butter with a knife, and you ask someone to cut butter and comes back with a chainsaw, right, to cut the butter. Cilium Service Mesh has a different approach. We want to keep it as simple as possible and also remove a lot of the dependencies or overhead other service meshes are introducing. So the goal is of Service Mesh with Cilium to reduce operational complexity. We also want to avoid unnecessary resource usage by running sidecars. We want to provide better performance through where we can to use eBPF. and avoid, obviously, any sidecar startup shutdown conditions or having to wait for a sidecar to be ready to accept connections while your application is being scaled out, for example. So let's dive a bit deeper how that works. Cilium runs as a daemon set, so Cilium agent runs on each node. And with Service Mesh, we use Envoy inside the Cilium agent for the proxy capabilities. So each namespace will get a dedicated listener powered by Envoy in Cilium, centralized on the node. So instead of having a proxy per workload, we use a proxy per node model, and we use eBPF to attach traffic to that proxy. This avoids the overhead and reduces resource usage. So instead of your workloads having to have a sidecar for each pod, we centralize that on the proxy, on the node level. So that saves you a lot of memory, CPU cycles. Also think about TCP/IP states you need to track. These are all going down, and that will improve performance. There's also a cost of sidecar injection in terms of networking. In this picture, you see, for example, some kind of workload sending traffic through a proxy on the wire. With a sidecar-based implementation, this basically means you go through the TCP/IP stack 3 times. On the sending end, on the application side, on the receiving side of the proxy, and again, from the proxy towards the physical NIC to another node, for example, your cluster. How we do it instead is to use eBPF to shortcut the connection directly from this application workload to the proxy. So on layer 4, on the socket layer, we can directly shortcut the connection to the actual proxy for east-west load balancing. So that means that eBPF, actually for layer 3 and layer 4 traffic, can directly forward and load balance the traffic across the wire. If you need layer 7 termination, you're using layer 7 path-based routing or filtering capabilities, then using eBPF, Cilium directly shortcuts that connection to the proxy. The proxy does the necessary processing, for example, that specific rule, and then forwards it again using eBPF on the physical network. And this reduces a lot of latency. We've seen 3 to 4 times improved performance in terms of latency, so lower latency. One of the most asked features we recently finally introduced was mutual authentication. So besides encryption, using IPsec and WireGuard, we've introduced mutual authentication through usage of simple Cilium network policies. This also has benefits because we're not bringing a proxy in the same layer as the authentication, right? We separate the authentication handshake from the actual encryption on the wire. That means that we're not limited to TCP only. We can also do that with UDP and other kinds of traffic. And we also keep secrets out of the proxies. We are not putting a proxy for a specific workloads in front of the traffic doing the handshake and doing the transfer of data packets. And obviously, that's a risk of being exploited. So doing that separation there as well has benefits. How that works is actually using simple network policies. So besides creating, let's say, a network policy for allowing traffic from a specific source on a specific destination, on a specific port or protocol, we can actually using 2 simple lines, authentication mode required, I hope everyone can read it, that will trigger Cilium to first enforce authentication. When you enable mutual authentication in Cilium, what will happen is that Cilium will install actually a Spirey deployment, Spirey SPIFFE deployment managed by Cilium, and the Spirey agent will communicate with the Cilium agent, for example, when it needs to be enforced, right? So when some kind of source wants to send traffic, the Cilium agent will ask the Spirey agent if this is a trusted identity before it's allowed to send traffic. So overall, Cilium Service Mesh provides layer 7 routing using ingress, using gateway API, observability fully powered through eBPF, so to get the best performing metrics, which you can export to, say, Grafana or other solutions. Security combined with network policies, filtering capabilities, high available service and resiliency. You can also match cluster mesh, for example, with Cilium Service Mesh. We're using your Kubernetes resources, so we're not planning to introduce a new control plane. You just use ingress resources or gateway API resources. You can even do envoy CRDs for advanced use cases. We don't see that a lot, so we recommend ingress or gateway API for simplicity's sake, and obviously Spiffy. If you already use an envoy-based sidecar, then it's still beneficial to run Cilium under the hood, because using eBPF, we will accelerate that data plane between the proxy and between the receiving or sending pods. However, if you have a choice to install new, you can already use Cilium for the data plane and also the service mesh capabilities. Since eBPF is so powerful for getting metrics on the wire, we also have partnership with Grafana. That means that we have a lot of out-of-the-box dashboards, so you can easily monitor traffic between your services. And this is so-called golden signals. This means that without instrumentation of your actual application, by just enabling, for example, a layer 7 network policy, we can already observe things like HTTP duration, response codes, latency, out of the box using our metrics. To summarize, with 1.14, and it's something I'm going to demo as well, we support cross-namespace routing, response and request header modifiers with Gateway API, also the capabilities of TLS pass-through using TLS routes, support in general for Gateway API 070, mutual authentication, WireGuard for encrypting the traffic, and also the capabilities to separate Envoy from the Cilium agent if you need to closely better monitor, for example, performance of Envoy versus Cilium. Let's dive into a few of the features, and I mentioned a few times already Gateway API, and this is obviously currently a project in the Kubernetes SIG networking space, which provides resources and also separation of roles, right? So as an infrastructure or platform engineer, you could manage the gateway class, you manage the platform, so you enable Cilium as a gateway controller. And then as an operator, you might want to create one or more gateways, maybe a shared gateway or a specific gateway per tenant or team. And then each DevOps team or application developer can attach and create and attach HTTP routes to their gateway they're assigned to, right? So it gives this clear separation. So let's provide a few examples. Cilium as a gateway relies obviously on a load balancer. So in cloud, you would rely on, for example, a Google load balancer being created to attract traffic into your cluster, and then forwards traffic to an ingress or gateway API resource to do the layer 7 matching. And we use this in HTTP routes to actually do the matching on a path or a service. And then you can forward traffic to specific services. So this is an example. You first need to create a gateway resource of the class Cilium. This will be a Cilium gateway. You create one or more listeners. In this example, an HTTP listener on a specific port. You can also use namespace annotations to allow routes from. So in this example, we allow traffic from the same namespace where the gateway is created. And then you create one or more HTTP routes. So in this example, I just reference my gateway as the gateway I want to attach this route to, and you create one or more rules. In this example, it's just a path-based rules matching /details to a specific service. You can also do TLS termination, so you can, for example, configure secrets in the namespace for your gateway. Gateway can use those to decrypt TLS traffic and then forward traffic to a given service. So you reference a secret, you listen on a specific host name, you attach HTTP routes, and in this example, again, a specific path. But you can also consider canary deployments using Gateway API. That means that you create HTTP routes, maybe with a specific header, matching specific traffic, so you can test your new version of your service in your application if it's working correctly before actually switching to that new service. This again works through simple matches on headers, for example, name of traffic, value of test, and I will show this in a bit as well. Also, percentage-based routing or traffic splitting is supported, blue-green traffic rollouts, so you can slowly introduce a new version of your application. Maybe first start with 5%, 10%, see if everything is behaving before flipping over all the traffic across the new service. This is done through so-called weights. So you specify the service and how much of that traffic, percentage of that traffic, needs to be forwarded to that service. You can add headers, you can modify headers, both response and requests. This can be useful as well for monitoring, tracking in your application and testing your application. And you can add responses as shown here. So this is all the slides part, and I want to show a few of these capabilities in a few demos as well. My first demo is a simple HTTP routing example. So we'll look at a gateway and two HTTP routes. It's a simple foo bar application, and the goal here is that all traffic to foo.example.com/login will be forwarded to the foo service. All traffic for bar.example.com will be forwarded to the bar service. And I'm also using the header matching to test a new version of my service. So let me quickly switch my screen. Can you in the back let me know if it's readable from there? Not really? Okay, let me improve that. Is this better? Good enough? A little bit more, okay. Right. Okay, so in sake of time, I already deployed a gateway. So let me quickly get my gateway. As you can see, it's already deployed and it has a public IP addresses. When you do this in cloud, it takes up to 30 seconds, up to a minute to get actually this service ready. So that's why I already prepared it. Let me show how this gateway is configured. Very simple, just gateway class Cilium and just a listener. That's all. Now I also have the foo service. All right, so this is the foo HTTP route. We're matching on the gateway. We're matching on a specific host name. And we also have a rule matching on a specific path. So let's apply this rule. And we also have the HTTP route for the bar service. And again, this one is a bit more complex because I want to test my new service. So I'm having an exact match on a specific nth canary header. This takes precedence over the default route. So any traffic matching with this header will be forwarded to my new service called bar service canary. And the backend other traffic will be default forwarded to the bar service. So let me apply that service as well. That's created. So these HTTP routes are now configured and attached to my gateway. I can do quickly get HTTP routes. They're ready. So now I can test this foo, and let me use my search to basically hit my login page. So this should, oh my God, what's the demo gods are not with me. What is happening? Oh my God, why? Let me see. Let me try the other one. Curl. Let's try the default service. Also not found. Wait, what's going on? Do I have my workloads? Oh. I know what I did wrong. So wrong. Okay. I deployed it in the wrong namespace. Very well done. Let me deploy them again. All right. So. All right. So now I've actually attached the HTTP routes to the right service, to the right gateway. So now I'm hitting the bar.example.com. And as you can see, we're getting a response from the bar service. Let me try the foo. All right. So this should be the login, because I created this specific match. Yes, I get a response from the login service. And now try the specific header matching and test if that works. So I'm adding a header, environment equals canary. And here I can see I can actually hit the canary page. So that's the first example how simple it is to create a gateway, HTTP routes, and get that working. Next demo is actually one which is also very common, is that you may want to share a gateway across different namespaces. You don't want to perhaps create a namespace or create a gateway for each and every team, because maybe it's costly, maybe you don't want a public IP per gateway. Instead, share it across teams. However, each team is running in a different namespace, so you need to match on a namespace and create rules based on that. And then each team in their own namespace can create HTTP routes and attach this to the shared gateway. Also note, in this example, we're doing a simple TLS decryption of that traffic. All right, let me switch directories. Shared cross namespace. All right, I should change namespace as well. So I'm doing the infra namespace. So I created an infrastructure namespace. I can see my gateway is deployed here. Also a public IP address. Let me change quickly the store namespace. Let me check the namespaces first. What I need to note here is that when I created my namespaces, I'm adding labels. So I'm adding a label, shared gateway access equals true. So for both the infra, the site, and the store namespace, we need to attach this label, because when we look at the gateway resource, we're going to create an allow route from a specific selector, right? So you can match on labels from namespaces. As a shared gateway, you can match those labels and have that matching there. And we're also decrypting TLS traffic using a specific secret. Let me quickly go to the store. So now I'm ready to create as a store owner, as a store team. I'm updating my application and I want to make that available. So that means for the /store, I want to forward traffic to my store service. So let's apply this HTTP route. Then the other team, the site team, manages the site namespace and the service is there. So let's check what we need to do there. Site, because there are some things happening here. Oh, actually, this is the home HTTP route. So what we're doing here is, again, matching the shared gateway to be used, and then forward it to a specific traffic. Basically, all other default traffic will be forwarded here. So let me do the apply for the home route. So this is now created. This means we can now use a test to actually see if this traffic is being forwarded to a namespace, and for specific URLs as well. So for the login, we should be forwarded to the login service. Also note that the login service, oh my God, I did actually something wrong. I also need to apply the login routes, and I will show you why. Okay. So we also have a login service, and what I'm showing here in the diagram is we also want to introduce this traffic splitting. So I want to 90% of my traffic to login version 1 and 10% to login version 2. So we're also getting this done through this resource. In this example, 70-30% for demo purposes. So forward traffic to login service will be traffic split across services. So let's apply that. Login HTTP routes. Am I still in the... Yes, I am in the namespace. Yes. All right. So let's do a curl for login. This is on, again, on the Cilium examples, example.cilium.com. So default traffic will be forwarded to the site, default site. That's fine. Let me check the, oh my God, the login. That works as well. I have a better example for this. Yeah, that works as well. So basically, this is all forwarded to the right service. Final example is that of a TLS pass-through and TLS route. So this allows you to not decrypt traffic, but instead forward it to the application based on a host, based on a specific TLS route. So instead of HTTP routes, we configure TLS routes. This is a new type of resource. And then we rely on the application to do actually the decryption of that traffic. So let me quickly change the namespace. And we'll go to the TLS demo. Also change the directory, TLS routes. So what I've done here, I've installed a simple web service, Nginx web service. The certificate is being decrypted there. We use the gateway to forward traffic to this service, and the TLS route will use forward traffic to that specific endpoint. So let's check out the TLS route. This is matching a TLS gateway for the specific purpose, and we forward it to a simple Nginx service where the decryption will happen. Let's check the gateway. So as you can see here, we're listening on a specific FQDN. And we're saying TLS mode pass-through. So we're not doing anything there. We're just forwarding the traffic. And we allow routes from all namespaces. So this is also already deployed. Let's check that. Yes, the TLS demo is deployed. All right. So let's try this out, and then we'll Nginx. So since this is a self-signed certificate, I need to reference my certificate I'm using here as a certificate authority, which has created that certificate. Where are we? Why is this not working? Curl Nginx. Oh wait, I already gateway. This should be the one. Okay. Why isn't? Oh, I got my laptop rebooted. Yes, that's what's happening. I need to get this IP obviously in my environment variables. So bear with me for a second. Yes, let me copy this. Yes, now it should work. Yes, we got a step further. Yeah, so what you can see here, we set the certificate. There's a TLS handshake. The end part, which I'm not going to figure out because my laptop rebooted, so my demo is not as ready as I should have been. So I'm sorry for that. But we can see that the gateway is actually forwarding to the endpoint, which is getting the traffic, but you cannot yet match that handshake. So I'm sorry about that, but I'm happy to demo that a bit later. But that's due to my laptop, so I'm sorry about that. All right, so to finish today's session, if you want to try this yourself, we have great Gateway API demos and labs set up on Isovalent website, on the isovalent.com/labs website. You can try Ingress, you can try mutual authentication, advanced Gateway API yourself. And also, if you're not part of the OSS community yet, feel free to join our Slack channels, give a star on GitHub. Happy to answer any questions there as well. If you want to know more about eBPF, please go to the ebpf.io website. That's also very interesting. And on that topic, we also have Wednesday eBPF Summit. You can attend that remote as well. And it will start in Europe time, 5:30-ish. So feel free to join that. There's amazing talks about this technology from people from Facebook, Netflix, and others, how they use eBPF for their use cases. So with that, sorry about parts of the demo not working again. So thank you for attending. I'm happy to answer any questions.
All right, we have quite a few questions, so let's jump in right away. The first one would be, in Istio, can you configure the envoy proxy to perform authorization requests against external services? How can this be achieved with Cilium?
Yes, so that's not yet ready with Cilium. So what we've done now is we basically built in the Spirey environment for authentication in Cilium itself. We're working on getting integration with external authentication providers as well, including self-managed Spirey or other solutions.
Nice. Does Kubernetes Gateway API take care of creating and managing cloud load balancers?
Yeah, so in this case, Cilium understands the Google API. So as soon as the Cilium Gateway controller receives a request to create a gateway resources, it will communicate with Google to get a load balancer IP address, and therefore we can attach that load balancer service towards the Gateway API resource. On-prem, you would use, for example, built-in Cilium load balancer, and then using our Go BGP control plane, you can actually advertise those IP addresses to the physical network.
Nice. I could have asked this question.
The answer is yes. Can I use Cilium with OpenShift? Definitely, yeah. We have a certified operator for OpenShift, so you can run Cilium as a solution on OpenShift as well.
So now I'm happy to know. All right. Other slide. Oh, yeah. The usual questions.
Yes.
I think the slide will be available online.
Absolutely. Yeah.
Just drop it. Maybe. Is there a current way to integrate Cilium Service Mesh directly to an open source CM for alerting and incident response?
Yes. However, not in open source. You could, however, export flows using JSON output and then using other solution to export that to SIEM. In our enterprise solution, we have a built-in component called Hubble Enterprise, which can forward all related flows with filters to an external SIEM solution.
When deploying Cilium and Grafana integration, are there any key differences when it comes to public and private cloud?
Depends. I'm not sure. I'm not as much of an expert on Grafana in private cloud, but I can imagine that you need to set up Grafana and then export metrics to your private cloud environment. Obviously, yeah, I'm not sure how to answer this, but it both works. It will depend on the Grafana deployment.
Do we have the one who asked this question here physically? 1, 2, 3. No.
Yeah, it just forwards traffic using Prometheus to Grafana, so yeah.
Should be fine.
Yeah.
Can you give an example where the TLS handling should be done by the application and not by the gateway? Good question.
Oh, that's a very good question. If you want to do it on the gateway from a security or platform perspective, you have the benefit of being able to see the flows, API calls, after the traffic has been decapsulated by the gateway. That has some benefits. You can, for example, get layer 7 information of your network flows, which allows you to also create Cilium network policies based on that layer 7 information, maybe specific gRPC or HTTP requests. You can filter on that, you can observe that. Obviously, when it's TLS, then it's not that visible. You just see it's TLS 443, or for example, you cannot do much with it. However, maybe for security reasons you want to, or specific application reasons you want to do this decryption on the application yourself, right? And then the team is responsible of managing the certificates, the life cycle and configuration of those certificates.
Is pod-to-pod encryption already possible with Cilium?
Yes, yes. Already for a few releases using either IPsec or WireGuard. So encryption is already in there a number of years.
And the two last questions. Can you implement ingress traffic policies, single point of ingress?
Yes, you can. You can use egress net policies. Those are specific resources in Cilium to, based on selectors again, to select, for example, a namespace or a pod based on its labels to go out with a specific IP address on a given node in your cluster. So the only requirement there is that you need to have those IP addresses configured on, let's say, a gateway node for this to work. And yeah, it's super dynamic. You can have multiple namespaces, multiple matches with different egress net policies.
I think you've already answered these questions during your talk. Can
Yes.
I do canary deployment with Cilium?
Yes, yes, you can. Using the examples I gave, yeah.
Any one last question in the audience? No? Then I think it's time for a big round of applause.
Thank you.